Hello everybody, welcome back to MrMiers Math channel. Today's an additional video to help you with preparing for that Chapter 7 test, which talks about radicals, rational exponents, and then some function stuff. So today it's just going to be a Chapter 7 review where I'm going to go through all the sections that we talked about in Chapter 7. So let's get into it. Alright, so first we're going to start with evaluating the expression. So we can use the calculator to do this. If we use a calculator, just remember we need to know how to use the calculator in order to type this in, but for most calculators it's pretty easy. Otherwise, you can go back to the section 7.1 video and check that out and figure out how to use a calculator to type this in. The 4th root of 16 is just 2. The 5th root of negative 32 is just negative 2. That's the number we can multiply 5 times to get negative 32. Alright, let's keep on going. There's a lot of examples that we're going to cover because remember we're covering every section. Alright, in example 2 we're going to rewrite the expression using rational exponents. Alright, so remember what we're raising this to goes on top of the fraction. The index goes to the denominator, so that's 8 to the 2/5 power. Notice that 2b is what's inside that radical. So 2b goes in parentheses, and we're raising 2b to the 4/3 power. All right, now we're going to go backwards. We're starting with rational exponents, and now we're going to get to radicals. All right, the numerator is what's on top. All right, and then the denominator is the index. All right, so we're going to have the cubed root of 16 here. All right, that doesn't look good. Let me write this again. There we go, that's better. The cubed root of 16. Now obviously for some you could write this as well. Raise that whole thing to the first power. It's not wrong, it's just a little redundant. Alright, then for part B, once again let's make sure 7x is what's inside that radical. 2 is the index, 1 is what we're raising this to. Both of those things are implied. Remember, it's not wrong if we do this. It's just a little redundant. Alright, let's move on. Alright, now we're going to simplify the expressions. So, whether it's using product rule, quotient rule, right here we're going to multiply the radicands. We get a 4th root of 32. Now from there, we still have to simplify. We could use a little factor tree. In this example, I'm going to do that. So 2 times 16 is 32. 2 times 8 is 16. 2 times 4 is 8. And then 2 times 2 is 4. All right, we need a set of 4. A set of 4 comes out. So right there, we've got a set of 4 there, and then there's 1 left over. So that set comes out, becomes a 2, and then we have the 4th root of 2 left over. So 2 times the 4th root of 2. All right, and the next one, multiply. So we have the cubed root of negative 27. We know the cubed root of 27 because we've done it so many times, and that's 3. The cubed root of negative 27 is just going to be negative 3. That's a number we can multiply 3 times to get negative 27. All right, 216 divided by 6 would be 36, so this is just the square root of 36, or 6. Awesome sauce. Let's keep on going. All right, now we're going to simplify some of these rational exponents. Okay, so if they have the same base, we can do this. So these two have the same base. Oops, pen tool. Now we're going to add those exponents. We get 9/3, which is 3. 6 to the 3rd is 216. And then here, we're going to add those exponents. So we get 8 to the 1/3 power, which is just the cubed root of 8, which is 2. And then for C, keep the base the same. Now subtract the exponents. We have 3 over 3, which is 1, which is just 9. All right. Now in example 5, we're going to use what we've learned to solve the equation. And then in some instances, remember, with some of these radical equations, we're going to have extraneous solutions. So be aware. All right, for part A, We got to get rid of that radical, so let's square both sides. So we get 2x equals 36, then divide by 2, and we get x equals 18. If we plug that back in, we'll see that it works. The square root of 2 times 18, which is the square root of 36, that is 6. All right, and the next one, let's add 12. So we get the square root of 3x equals 12. Square both sides to get rid of that radical. We get 3x equals 144. And then we're going to divide by 3, and we get 48. Awesome. And the next one. We've got to use inverse operations to solve. So the first thing that we got to get rid of is that -2. We want to isolate the radical. So divide each side by -2. We get the square root of 2x minus 1 equals 5. Now square both sides. We get 2x minus 1 equals 25. Add 1. We get 2x equals 26. And then divide by 2. And we get x is 13. If we plug that back in, we'll see that it works. 13 times 2 is 26. Minus 1 is 25. The square root of which is 5. And then -2 times 5 is -10. All right, the next one is the first one in which we get an extraneous solution. Notice the setup of this one. We have a radical of an expression equals x, and that is going to give us, once we go about solving this, it's going to give us an extraneous solution. All right, doesn't happen all the time, but a lot of times. So first thing that we're going to do is square both sides. So we have 40 minus 3x equals x squared. Then we're going to get everything over to one side. We notice that this is a quadratic, so add 3x, subtract 40, so we can try to factor. All right, hopefully it's factorable in this case. It is factorable. This quantity is just x plus 8 times x minus 5. Set each equal to 0 and we solve, and we get -8 and +5. And in this case, it's the negative that doesn't work. All right, if we plug it in, all right, 40 minus 3 times -8. 3 times -3 times -8 is 24. So we get the square root of 64 equals -8. The square root of the square root of 64 is 8, but 8 doesn't equal -8. So that's why this does not work. All right. Now we're talking about functions. Okay, so we diverge a little bit. Now if we want to do f of x minus g of x, we have 2x plus 5 minus that whole function. We have to subtract the whole thing, so put it in parentheses. So then we can distribute the negative to both of those terms, and then combine like terms. We get x plus 8, and the domain of that is going to be all real numbers. F of x times g of x is just going to be 2x plus 5 times x minus 3. All right, and then we're going to have to FOIL that out. All right, so if we FOIL that out, we're going to get 2x squared. Multiplying the first terms together, the outer terms together, inner terms together, and then the last terms together. So we get 2x squared minus 6x plus 5x minus 15. Combine our like terms, and we get 2x squared minus x minus 15. In this case, once again, our domain is all real numbers. All right, in the next example, we're still creating these new functions, but some of these are going to be compositions. So in part C, we're dividing, so f of x divided by g of x. And in this case, there's no common factors to cancel out, so this is it. There's our new function. But the domain is going to be different. It's not going to be all real numbers this time. All right, there's a value of x that makes this function undefined. all we have to do is set the denominator equal to 0 and solve, and we get x equals 3. That's the value for which this function is undefined, so x can't equal 3. It can be any other real number, just not 3. If we look at part D, now we have our composition. So we want to find f of g of x. So that means we're going to take g of x, plug it into f. If we do that, we have 2 times x minus 3 plus 5. And then we distribute, combine like terms, and we get 2x minus 1. All right, the domain for which is going to be all real numbers. Okay, as long as we don't have a variable in the denominator, the domain for these is going to be all real numbers. All right, now we want to evaluate. So in part E, we have f of g of 4, so we're going to plug 4 into function g first. Let me erase this overhead. All right, so g of 4 is going to be 4 minus 3, which is 1. And then we're going to take that output value and plug it into f. That's what it's saying. F of g of 4 just means plug 4 into g, and with whatever you get, plug that into f. So now we're going to do f of 1. That's 2 times 1 plus 5, which is 7. All right, so 7 is f of g of 4. All right, in part f, let's first plug negative 1 into function f. So that's going to be 2 times negative 1 plus 5, which is 3. And then we're going to take that 3 and plug it into g. So we have 3 minus 3, which is 0. Okay. All right, so now we're going to find the inverse of each function. In order to do that, remember, let's rewrite it. And then we're going to switch the inputs and outputs. And then solve for y. So subtract 25. Divide by 5. And we get x minus 25 on 5. All right, for part B, same thing. Rewrite it. Switch our inputs and outputs. So x equals 4 plus 4/3 y. Solve for y, so subtract 4. And now multiply by 3/4 on both sides. So we have 3/4 times the quantity x minus 4. Awesome. We're almost there, folks. In this next one, remember we want to take the square root of values that are going to give us some nice and neat output values. So those values, remember, were 0, 1, 4, and 9. In this one, we can just plug those into the to our domain because there's nothing else inside that radical. So we have the square root of 0 minus 1, the square root of 1 minus 1, the square root of 4 minus 1, and then the square root of 9 minus 1. All right, that'll yield output values of negative 1, 0, 1, and 2. We can plot those values and then graph our function. All right, the next one's going to be a little bit more useful, okay, because there is something happening inside that radical. All right, when there's something inside that radical, we just want to figure out what does x need to be for us to get 0, 1, 4, and 9. That'll yield some nice and neat output values for us. Okay, so let's set x minus 2 equal to 0, 1, 4, and 9, and then solve those equations. So we get x is 2, x is 3, x is 6, and then x is 11. So there are our input values. All right, so then when we plug those in, when we plug 2 in, we just figured out what x has to be to make that square root 0. Okay, so this output value is just going to be 0. All right, when we plug 3 in, we're taking the square root of 1, which is just 1. When we plug 6 in, we're taking the square root of 4, which is just 2, and then we get 3 when we plug in 11. Let's plot those values. Approximate that one, and then draw the graph to the best of our ability. Awesome sauce, folks. If you have any questions, make sure to email me. If you enjoyed this or found this helpful, please like, share, and subscribe. Thank you, and have a great day.